Hello everyone, thanks for joining my talk today. My name's Izzy, I'm Technical Content Specialist at CoolEd, and if you haven't heard of us, we're an organisation that specialises in LED microscopy illumination. And today I'm going to touch upon how this technology really lends itself to wide field fluorescence imaging when you're using multiple fluorophores and you need high speed and high contrast. So it might come as a bit of a surprise to think of the light source as enabling high-speed imaging. This is what I'm going to explain here. So firstly, it's not just any LED illumination system that can enable this. You need to look out for two different features. The first is individual channel triggering with TTL. And the second is the ability to house excitation filters within the light source itself, like in the PE800 shown here. This is the filter holder, and the single band excitation filters just fit in these slots. Then you need to consider your filters. With a Pinkel configuration, which has single band excitation filters, these can fit into the light source, and then you have your multi-band dichroic and emission that sit in a single filter cube. And when you're using multiple fluorophores, instead of having a filter wheel, you don't have any mechanical movement, you're just relying on the LED triggering. This can be as fast as sub-7 microseconds. So you're really capitalizing on the speeds available here. However, it still has a multi-band component, so it can risk crosstalk. And if you want higher contrast, then a Sadat filter set can be used, and the single band emission filters can be housed in an image splitter or a camera splitter. So it's higher contrast, but it also comes with a higher price tag. If you want to take this approach to the next level, Sequence Runner is a function that's available on several of our products at CoolEd. And this automates illumination. And the only extra equipment you need for this is a camera with a TTL output. So once you set up your LED sequence on a manual control pod or Lightbridge graphical user interface or on software, press go, and this sequence automatically synchronizes to the camera. And when the light source receives a TTL signal, the next LED is triggered, and so on. So this is a really neat feature, great for high-speed imaging, but as mentioned here, synchronizing the camera and the light source is also great for live cell imaging because it reduces the risk of phototoxicity, because you're only exposing the sample to light when the camera is acquiring an image. So great feature, but we feel sometimes it's very much underutilized. And finally, I'm just going to end on a bit of an overview of our product range. So I've mentioned the PE800 here, which is our 8-channel system for advanced research, but our products come in all manner of shapes and sizes. So we have LED illumination systems for calcium fluorite imaging, and our most popular product range is the P300 series for everyday fluorescence. And there are also single channel systems for screening and transmitted illumination. And most excitingly, we have a brand new product on the way very soon, and we'll be launching this at ASCB. So if you're going to be at the conference, then please do pop along to our booth and see it in action. But in the meantime, thank you very much for watching my presentation, and if you have any questions, my colleague Brad Reynolds is at Woods Hole, so please do ask him if you need any more information.